Well, here I want to introduce a very basic concept in college or advanced mathematics, that is derivatives, by using regression models or basic math equations as a case in point. So let's say here we have a very simple linear relationship between two variables x and y. So in this case, both beta 0, so beta 0 and beta 1 here, using Greek notation, are constants, and x, y are variables. Beta 0 is what we call constant or intercept in statistical terminology, and beta 1 is the fact of x and y. And in statistics and data science in general, we want to actually describe the effects of x and y, and that boils down to describing beta 1 or kind of looking for beta 1. So again, let's use statistics as an example. Usually we have a function for the association between predictor y, x, and response variable y here. So y is a function of predictor x. In most cases, we usually have a collection of predictors, but to simplify the example here, or simplified discussion here, we simply use one single predictor x. So for example, here we have a linear relationship, y equal to beta 0 plus beta 1 x. Again, let me reiterate, y and x are variables, and beta 0 and beta 1, they're constants. In social science, usually we want to figure out exactly how y responds to x. So y here is the response, and x is stimulus, right? And that is what we call effects. How x affects y. What are the effects of x on y? Or sometimes we say the association between x and y, if we kind of refrain from giving a definitive causal description. Okay? How to describe the relationship? Okay, usually how to describe the effects? Usually we say, well, let's change x by a certain amount, and let's see how y vary in response to that amount of change. So here we change x0, x from x0 to x1, and then for y we get f of x0, right? And then we get y, which is equal to f of x1, right? F of x1 is basically, y1, right? The value of y when x is equal to x1, right? So in the numerator is the difference in y, and in the denominator is the difference, the amount of change in x, right? So that becomes this quantity, this ratio, and then we simplify the expression by delta y, which means the difference in y, over delta x. That is the amount of change in y in response to the amount of change in x. That's what we call the effects or the association. Or mathematically, we call that delta y over delta x. That is change in y in response to change in x, or the rate of change. Here I can give you an example. And for example, y equal to 4 plus 0.5 multiplied by x. So the intercept is 4, and the slope is 0.5. Here is beta 1, right? Here is beta 0. How about x at any given value increasing by 1 unit, 2 units, 5 units, and 10 units? Okay? And then we calculate the corresponding y, take a ratio of delta y over delta x. What we're going to get? We will have a constant effect, it turns out, if we have a linear relationship here. So here's a graphical presentation of the relationship, right? Here's an x, here is 0.5 multiplied by x plus 4, right? Now this equation here. So let's change x from 2 to 4. So the delta x is equal to 2. Then what's going to be the change in y? So when x equal to 2, right? We plug in a number here, 2, and this becomes 1 plus 4. Y0 is equal to what? 5. Then we plug in x equal to 4 here. So plugging x equal to 4 here, this term becomes what? This product becomes 2. 2 plus 4 equal to 6. So the second y, that is y1, becomes 1. That is the difference in the two y's. The first y equal to 5. The second y equal to 6. The difference is 1. And if we take a ratio of delta y over delta x, that becomes 0.5, which is equivalent of beta 1 here. Okay, let's try another example. Let's say we increase x from x equal to 6 to x equal to 7. Okay, 1 unit difference, and we're plugging number equation here, and we calculate the two y's. It turns out that the difference in y is equal to what? Equal to 0.5. So the ratio here is again 0.5. And that captures the association between x and y. So in this case, we're going to say, well, regardless where we're going to go, the effect of x and y is 0.5. That is, for each unit increasing x, we would expect y to increase. Because here, the coefficient is positive, is going to increase by 0.5, on the scale of y, or y unit. So what is the catch point? The catch point here is if we have a linear equation like we do here, the effect of x and y is a constant represented by the coefficient in front of x here, the linear. When we say there's a linearity, we say the relationship either additive or multiplicative, without any polynomials or nonlinear functions.